All right, lesson 47 practice for course 3, graphing functions. A, it says, the directions on the paint can describe a function. 1 gallon covers 400 square feet of sealed, non-textured surface. On graph paper, draw and extend the axes like the one illustrated, then create a function table relating quantity of paint in gallons, G, to the area covered in square feet. Use the numbers from your table to graph the function on your paper. So you notice my number A, I did the table first. So this will help me do my graphing. So if you look at your table, we've got 0 gallons is going to cover 0 square feet. 1 gallon covers 400 square feet, 2 gallons, 800, 3 gallons, 1,200 square feet. So now what we can do is we can use these to make our table. Now the paper says use graph paper. We could use our coordinate plane, but do we need quadrant 2, 3, and 4? Because it's only positive numbers, right? We are not peeling paint off and putting it back into a can. We are only using positive numbers. So what we're going to do is we are going to use our ruler to make these things equally spaced. Now I have my lines over here. Pretend those lines are my paper. Okay? So what we're going to do is we are going to copy that table. So I'm going to use my ruler. You will use your ruler. I'm going to draw a straight line going down the paper. I'll use my ruler on the bottom half. Now, I'm going to make sure I have enough places. So what does the y-axis mean in this one? Is it gallons or is it the square foot?
Square feet.
Square feet. So I'm going to put here area in feet squared. And I'm going to start down here at the bottom. And I'm going to say this one is 0. Do I go 1, 2, 3, 4, 5? 100, 200. Notice I'm putting it like in the middle of the line, not on the line, because that line I'm going to use to represent 400, 500, 600, 700, 800, 900, 1,000, 1,100, 1,200. The next thing you're going to do is for the x-axis, you're going to take your ruler and you're going to decide on the correct scale that you're going to use. Over here, I went to 3 gallons, but if you look at your graph has you doing it every quarter of a gallon. Do you agree? Every quarter of a gallon? So if I'm going to go at least 3 gallons, that's 3 times 4 quarters. I need to go at least 12. So if I look here, I might use centimeters for mine. You might choose to use a 1/2 inch. You might choose to use a 1/4 inch. Whatever you choose to do, make your scale. Here, I can't go 12 inches across. So if I chose to use a 1/2 of an inch, my lines would look something like this. Here's a 1/2. Here's a 1/2. Here's a 1/2. Finish your scale on the bottom, number it, and then you can unpause the video. All right, if you're watching the video, you have your whole x-axis finished. I'm going to remove my ruler, but before I do, I want you to look one more time. It is marked at every 1/2 inch for me. So I'm going to remove that ruler. And you'll notice on the graph, not only did I number it every 1/4 of a gallon, which, by the way, a 1/4 of a gallon represents what measurement? A quart. Very good. So I go all the way to 3. I have an arrow saying it keeps going because if I buy more paint, I can keep going. I also labeled that gallons. Now this is a graph of 2 different things. What would be a good title for my entire graph? Yeah. Coverage in feet squared of paint. Something to describe that situation. Now, going back to my table. 0, 0. This is my x-axis and my y-axis. I'm going to put a dot here in 0, 0. 0 gallons, 0 paint. 1 gallon coming perfectly straight up would be 400. 2 gallons going perfectly straight up is 800. If you need a ruler to go straight up, use it. 3 gallons goes up to 12. And now my question to you is it only going to be those numbers like a step function, or can we connect it like a continuous function? Yeah. Could you flick just a little bit of paint on the wall and cover some of it? Yeah. So this is going to be connected with a ray that goes through those points. A ray. How close are mine? Mine are pretty close. So we have a ray going through those points. Every spot on that ray represents how much paint we can cover. So at that point, we've answered all parts of A. Take a look at question B. Referring to problem A, which equation below describes the relationship between the number of gallons of paint and the area covered in square feet? So I have those equations right here, part B. We have A equals 400 plus G. Is that true? No, because if I have 1 gallon, it makes area 401. If I have 0 gallons, it makes area 400. So that doesn't work. B, area equals 400 times G. 1 gallon is 400. 2 gallons is? 3 gallons is? Okay, so is that one true? All right, so what I'm going to do is I'm going to write down B. Let's look at why C and D are wrong. Area equals 400 divided by gallons. What happens with the more paint we buy? Less area covers. If I bought 400 gallons of paint, I would only cover 1. So if that was true, I would only buy 1 gallon so I can paint a lot. Last one. What's wrong with the last one? If I bought 1 gallon of paint, how much area do I cover? 1/400th of us. Yeah. So it's very obviously that is the correct one. Agreed? All right. So now look at number C. Does C ask you? What does C ask you to do? Paint how much? 700 square feet. Let's use the equation first. If I wanted to use the equation to solve this, my equation was area equals 400 times gallons. And if they want me to cover 700 square feet, I can substitute 700 in for area and divide both sides by 400. Cancel, cancel. 7/4 gallons, which is 1 3/4 gallons. How could I use the equation to get that same answer? I mean the graph. So let's take a look at our graph and see what happens. I'm going to change. Let's go with a red line right here. Let's go this one. Let's go red line. Okay, so I have a red line. If I want to paint 700 square feet, I'm going to start here at 700. I'm going to draw a line over. And then with my ruler, I'm going to draw a line straight down. Our graph is pretty accurate. Where does it cross? At 1 3/4. So we can use the equation or we can use the graph. But either way, we should get an answer of 1 3/4 gallons. Now, if you were painting this room, would you buy 1 3/4 gallons? You would probably buy 2 gallons. Can you buy 3/4 of a gallon? You can buy you can buy paint by the quart. So you absolutely can. You probably can't go in and buy a tablespoon of paint. But you can buy, I think, up to about a half of a cup. because you can buy test cans where you put it on the wall and see what you think. So now, looking at C, is there anything we did wrong? Yeah, they're not asking for how many gallons, they're asking for quarts. So if 1 quart is 1/4, what's going to be my final answer? 7 quarts. 4 for the gallon, and then 3/4 makes 3 more quarts, 7 quarts. So now I'm going to ask you to pause the video, and I want you to do problem D. Use your ruler to make sure you have equally spaced parts, but I want you to graph D and see if you're right. Every year, it's missed. So be better than the others. Go. So if you've hit play, you've already graphed it. So I'm going to look at a couple things here. My x-axis, because my x-axis was called the input axis. Input is x. This is my elevator button. So in other words, when we push buttons, it's the floor. So these would represent the floor that we are on. And this would be elevation. Now the only difference in my elevation is it's not elevation 1, 2, 3. It's elevation 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130 above the street. So my graph title could be elevation above street and floor. There's my relationship between those. If you have not graphed your points, pause the video again, make corrections, graph your point. All right, let's check out your graph one. What was the input? Yes.
Input would be like X for 1.
Okay, input is X or 1, but in this problem, what's the real life input?
What button you push?
What button I push. Okay, what button I push. Now, what I'm going to do is, it didn't ask me to do this, but I'm going to make a table. So if you don't have one, let's add it real quick, a table. The button I push and the floor, not necessarily floor, but my elevation. So button and elevation, elevation above the street. Now, the first floor is usually A, or lobby for L, or 1. It can be a couple things. But if I'm on the first floor, how high above the street am I? 0 feet. So if you have 0 matched with 0, there's no 0 floor. It's the first floor is 0. The second floor is how much? 10. And how many floors are there? So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And over here, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Which, now my graph, I'm going to use blue so it shows up, is 1, 0 right here. 2, 10, 3, 20, 4, 30, 5. Go ahead and get all your dots. So there's my completed dots going up. Now my question to you is this. I looked around the papers. Some of you connected it with a line. Do we connect this or do we not connect this?
You don't connect
Why do we not connect it?
because you can't push a button 1 1/4.
There is no 1 1/2. There is no 1 1/4. We can't push a button. Since we can't push a button, we do not connect it. So is this a continuous function or a step function? It is a step function. So if you have any questions, make sure you do ask me, but see how the table does help us make the graph But the next question, question E, asks what is the domain of the function? Remember, domain becomes all of our x values. So when I take a look at this, my domain is simply going to be the buttons I push. So my domain are all of, you could say the counting numbers 1 through 12, or let's go down here. You could say the domain is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make sure you put it in set notation. And that's our domain. What's range? No. What's range? How about 0, 10?
0.
Yeah, range becomes my y values. So 0, 10, 20, 30, 40, 50, 50. And go ahead and keep going. 60, 70, 80, 90, 100, 110. And that would be my range. Even though the book doesn't ask it, it's good to know. So that takes us to the last question. The last question says, is the relationship described in problem D proportional? Why or why not? Is it proportional? I got yeses and I got no's. So let's go with the answer is no, and let's prove why. No. Remember, proportional has to be a straight line. Are the dots in a straight line? Yes. So it meets that requirement. But it's a straight line that goes through 0, 0. Does your graph go through 0, 0?
No.
If you need to look back, no, it doesn't. So no, it does not pass 0, 0. What's the other way we could have checked to see if it's proportional? Yeah, some of the ratios. Remember, we've got elevation over button. So 0 over 1, 10 over 2, 20 over 3. Here we get 5. Here we get 6 2/3. We can already see that it is not proportional. Any questions? I want you to come up with what the equation of this line would be. Pause the video, come up with the equation. All right, for the sake of time, hopefully you had your chance. A equation says what to do to the input to get the output. So my elevation is going to be equal to 10 times the button I push minus 10. 10 times 0 minus 10 is 0. 10 times 1, 10 times 1 minus 0, or 10 times 1 is 10, minus 10 is 0. 10 times 2 is 20, minus 10 is 10. So this right here also tells us it's not proportional, because all proportional graphs, none of them have anything you add here. It's just y equals ax. You may stop the video after you have your notes. God bless. Have a good day.